So this was the question of lecture number 10, that you have to find the product in this case. So this is the pattern of this is chlorobenzene and substitution at ortho and para position, NO2 at ortho and para position. So this will certainly enhance the reactivity of this chlorobenzene compound, chlorobenzene derivative. And this is your C2H5, and here C2H5O is what, nucleophile. So only the substitution will occur. So the final product in this case, I think very simple question, no need to go for any explanation, because we had already discussed it in very detail in this lecture, in that lecture only. So the NO2 here and NO2 here, without any disturbance, you just put the nucleophile. Okay, nothing else, everything is fine. So this was the only question which I have asked you in that lecture number 10. Thank you so much. So this was the question which we have asked in I have asked in lecture number 11. Let's start the solution. As you can see that C7H7Cl and one benzene ring is there, so there is no need to go for any other thing. We have one benzene ring, so this benzene ring always contain what, uh, C6H6, and this is C7H7. So what we required here CH3 and one Cl is there, so this is the Cl. So this is the first isomer, then this is ortho, then you can go for meta, then go for para. So the second is meta CH3, and the third one is the para. So we'll go for the third one, that is the para, and then we go for the side chain also. So side chain here, CH2Cl, which is possible, another. So uh, this is the I think complete isomer, we cannot go for further. So we can go we have four isomer in this case, we have four isomer. Now thing is what, uh, which one is the weakest bond. So as we had already discussed that this CCl bond will be what, resonance stabilized, this will be resonance stabilized, this will be resonance stabilized. Only this is not a resonance stabilized, because this is a single CCl bond. In other cases we have double bond. So out of this, uh, this is the case of weakest CCl bond. Okay, so this is the answer of the question. Now moving for the second question, para isomer of dichlorobenzene and higher melting point. So this is the para isomer, this is the chlorine, and this is the para isomer. Just look at the structure, this is very symmetrical structure. This is what, very symmetrical structure, and this symmetrical structure will give you close packing in crystal lattice, close packing. Okay, and close packing in crystal lattice leads for what, this will lead for the better intermolecular force of attraction. Okay, it has great intermolecular force of attraction, and as the internal force of attraction is higher, then you require higher temperature or higher energy to break this bond, and of course if it is, then the melting point will be increase. So this is the reason that because of the symmetrical structure, it has close packing crystal lattice, and this will lead for the result of this is what, greater intermolecular force of attraction. And definitely as the intermolecular force of attraction is higher, then we require higher energy to break this bond. Okay, So this is the answers of the lecture number 11 questions. I think this solution you will find well. Okay, thank you so much. Okay, so this was the question which I have asked in lecture number 12, that the vinyl chloride is an aliphatic halide, but it resembles with chlorobenzene in its property. Why? So as I told you, this was very simple question and answer is already given into the solution. So here I'm just showing that the slide, as you can see that this is the vinyl, this is the vinyl chloride, and this will give a carbon double bond of because of resonating structure. And this is the aryl chloride, this will again give the carbon double bond X in resonating structure. And this is the reason that both shows the that means the vinyl halide shows the resemblance with um, aryl halide in terms of property. Okay, this we had already discussed, so I don't think that it was a very difficult question. Okay, this was very simple question. Thank you so much.